So I'm really happy to see there's a lot of people interested in learning about this stuff. But before we jump into the nitty-gritty stuff, let's have a quick word about us. So my name is Daniel Deogun, and I work at a company called Omega Point, which is a consultancy firm that specializes in the crossing between application development and security. And who are you, Daniel?
Well, my name is also Daniel, but Daniel Sawano. I work at a company called Avanza, which is an internet-based stockbroker in Sweden. To give you an idea of size, we're the biggest actor on the stock exchange in terms of sound feedback and trades. So enough about us. If you want to find out more about us, just check out Google. So,
cracking the code. What's that really about, Daniel?
well, the thing is, when we think as a developer, when we think about, a security bug, a security issue, we kind of get scared, and I think it's something mystical about it. We think we can fix regular bugs, but we can't fix security bugs. Security bugs are for those people in black hoodies.
So a security problem is, if I understand you correctly, is something scary that somehow is unexpected. But isn't that the same thing with a bug?
Yeah, and that's the thing. When you think about it, what really is a security issue? A security flaw is when a piece of software does something that it wasn't intended to do. Some evil hacker makes it do something it wasn't intended to do. But isn't that just, as you said, isn't that just what all bugs are about? The program does something it wasn't intended to do.
As developers, we're really used to actually addressing problems by using good design, right? And that's how we fix those problems. Couldn't we do the same with security problems then?
Exactly. So just like we're fixing normal bugs with tests, good design principles, and everything like that, what if we could use the same principles and apply them to build more robust and more secure code? And that's really the essence in this title. We're trying to demystify the concept of security bugs being something magical. And it's also a part of a broader concept called secure by design, which kind of focuses on this, being able to apply good design principles and get security benefits as a kind of an implicit benefit.
So today, in order for you to understand what we mean by applying good design principles to fix security problems or to crack the actual code, we're actually going to cover three things. The first, we're going to show you how we can address a typical security problem and apply, design on that and have it go away. And then we're going to look at mutability, right?
Yeah, because mutability is a source of a lot of problems, one of them being security issues. And we can see how we can solve our need for mutable state by making the state immutable.
So the immutable mutability, that's weird. Okay,
let's
wait for that one. And then we're going to look at accidental leakage. And according to me, at least, that's one of the most common problems out there, that we accidentally leak out sensitive information into, I guess, logs or whatever it is. And we have a design pattern that can help you detect those kind of things.
Yeah.
All right. So let's jump into the first classical problem, cross-site scripting.
Cross-site scripting. Yeah, we all heard about it, and it's very common. We're unable to get rid of it. So what is cross-site scripting?
Well, typically we would have some sort of web form, right? And on this web form, we would enter our phone number, for instance. And, that works fine until someone that's, evil, they would put in some, JavaScript. And that JavaScript gets stored in the database, for instance. And eventually it pops up on a web page and it gets rendered as code and executed, right?
Yes, you get a pop-up, and typically maybe the one who's looking at getting a pop-up is not the same one who entered the code, right?
That's right.
So that means if I don't have a database, I'm safe, right?
No. This is just one example, of course. I mean, the other one would, of course, be a reflective one. And the reflective one is quite similar. The only difference is that we don't store it in a persistence layer. We would probably echo our input verbatim. Could be in an exception or some sort of failure message. Or
Okay, so we're sending the bad input back as an error message, for example, and then you get the pop-up again and you failed.
Yes.
And I guess if it's an exception, it's going to end up in a log file, right?
That's
so then
right.
you could then you'll have your like administrator looking at a log viewing tool, and you will get an exception there. I'm sorry, a pop-up there on the administrator computer.
Exactly, and that is actually a second-order injection attack, but we're not going to dive into that right now.
Well, okay, I think I understand the basic concept of process scripting. So how do we solve this?
So if we look at this from a technical perspective, the problem here is that we have forgotten to escape the data before it gets rendered in the web browser context, right?
Okay, so by escaping, you're meaning, in this case, we're going to render the data in a browser, so we need to make sure the encoding, if you will, is correct for that type of rendering.
Yes.
So if I would be rendering it, I don't know, in JSON, I would use appropriate encoding for that.
Exactly.
Okay.
So if we would apply the technical solution to this, of course, we would use escaping. Very easy, right? All the frameworks does this for you, and we're all sound. So why is this, I mean, I think we were going to talk about design. And, I mean, this is not design. This is, framework.
Yeah, it's kind of like we're solving the problem on the infrastructure level.
Yeah.
So, and that's a good, approach, but we still seem to fail, so we're missing something.
Okay.
So what if we apply this concept as called, security in depth?
Okay.
Which essentially means you want several layers of security. So if you were able to bypass one layer, you can, protect yourself at the other layer. And that's when what if we can, protect ourselves at the domain layer, the business code that we write? That would be pretty cool.
But in order to do that, I don't want to think about security. So let's take another look in another example. And this is a real-world example where they had this bug.
A regular bug, right?
A regular bug.
Yeah.
And this bug was that, well, there was an international retailer. They were not selling books.
But they're selling stuff on the internet, a lot of stuff.
And what they did was that they had this penetration tester team that was there, and they were trying to attack their site, like pen testers do. They didn't find anything until one of the guys actually entered a -1 into the quantity field. So
that when it got really interesting, because as you can see, suddenly you got kind of like a do-it-yourself discount voucher. Pretty neat. Right? You buy a couple of books, now I want to get a discount, so you just add a minus Hamlet.
I think they just thought that this price was more reasonable.
Yeah.
Right? It's pretty good. And as it turned out, the company, they did a full analysis of this. And it turned out that this feature had been there for years. And people had been using it.
Yeah. You could find this information like on forums and internet. Put in this and you can get a discount. So they had actually lost quite a lot of money. So, once they realized this, what did they do? Did they go after all the users who, cheated and sue them?
I mean, that's one approach, but they decided to write it off and say, let's just address this, fix this. And so that's good for now.
Okay, so instead of pissing off everyone, you just say, no, the problem was our mistake, so we're just going to take the losses.
So let's analyze this now from a domain perspective.
Why did this bug even occur in the first place?
So if you look there on the left, we have some sort of mathematical context, right? The -1 is part of something we call an integer.
Yeah, and when they wrote the code for the shopping cart, they figured, we need a shopping cart and we need to add items to the cart. They have a price, they have a quantity, and what's a quantity? Well, it's not a decimal number. It should be an integer.
An integer.
It's an int.
Okay.
Pretty easy.
So that makes perfect sense. But the problem is that quantity isn't an integer. I understand it looks like an integer, but it doesn't behave like an integer. Do you remember your math from, 20, 30 years ago?
You mean 5 years ago?
Yeah.
No, not really, but please refresh my mind.
Okay. So integers, they're actually part of something called an abelian group. They form an abelian group, right? They're closed under addition, which means that if you apply these various operations, you get another element inside of that group. They're actually an abelian ring as well, because they're closed under multiplication as well. That's an integer. That's how an integer behaves. Quantity doesn't behave that way.
Okay, I kind of get what you're saying, but I don't really understand the Boolean stuff. But one thing I do understand is that I know that the quantity in this web shop cannot be, integer min value or integer max value. You can't buy that many books in one order.
It would be fun to go to shipping and say, please ship 2 billion books to this address.
There's always a constraint in a typical business domain.
And honestly, what's a zero quantity? It's like, I have no computer in my order. I have no pizza in my order.
You can have a pretty big order with no items.
Okay, yeah. So I guess we can conclude that even though quantity looks like an integer, it doesn't behave like an integer in all aspects.
Okay, so what should they have done instead of representing the quantity as an integer? That's the question. So if we jump to domain-driven design, some of you might be familiar with it, there's a concept called value objects. And a value object is essentially you choose to represent something in your code that is an important concept in your current domain, all right? And so you choose, since it's important, you choose to represent it explicitly in your code. And what if we take that concept and we enhance it? We say not only is it going to represent an important concept, but we're going to put a lot of domain invariance in it and say that it can only exist if it represents a valid value.
So there must be an important concept in your business that means something to the business. If we would talk about books and shipping, all that stuff, the domain experts are probably not talking about integers. They're probably talking about quantity of books.
So in this case, maybe a valid quantity would be 1 book up to, let's say, 99 books, but no more.
Okay, and it's also immutable, which means that it can't change, right?
Exactly.
Interesting. But if you look at code, this is a typical implementation of a domain primitive in Java, right?
Yeah. So the quantity in this case would be, we make the class final, we make it immutable. As you can see in the constructor, we're upholding all the domain invariance that is, stated from the business. 1 to 99 is a valid quantity. And then, of course, it will contain all the domain operations that you can do on this object. So it's not just a simple DTO object, it's not just a data holder. This is a typical implementation of a domain primitive.
And of course, this looks a little bit bulky because Java can't create actual types, right? I mean, you have to use a class or something that sort of represents that type. But if you had used Ada, for instance, you can define your type with these constraints and say, if you're going to use this type or say something that is this type, you have to apply these rules on it.
Yeah, and that's an example of where you have a programming language that supports it. But the important idea is that if you have an instance of this type, it's valid in your current context.
So this is super interesting. This means that we can actually create something that's very specific to our business and make sure we only create something that is valid by definition. So if we apply our same analysis that we did previously, we would see there on the left that that -1, it gets rejected by design or by definition. Why? Because quantity is defined between 1 and 99. Okay, so if this is the case, we know that domain primitives, this design pattern, it tightens our design and it expresses our requirements and assumptions explicitly rather than implicitly, like we had with our integer.
Okay, so now we have a design pattern to solve a regular bug. Let's see if we can apply this pattern of domain primitives to the cross-site scripting example, so we can see if we can solve a security problem.
So I guess if that works, we have successfully shown you a way to address, I guess, a technical security problem just by using a design concept without actively thinking about security. So let's see how that works. Okay, so let's rehash this once. So the cross-site scripting, we have our web form, our phone number, enter the phone numbers that are valid, everything is nice and dandy. But if we enter the script, all of a sudden that pops up on the web page, either if it was a stored or a reflective or something else. Right?
An interesting part is, why did that happen? Well, on the server side, you have this method called register that handles the input, right? It takes a phone number of type string and then you do something with it. And the interesting part is developers, they will look at the parameter name. It's a phone number. So I know I do a cognitive mapping that, well, it should be this format and therefore I can do these operations on it.
To be honest, we glance over the type and say, yeah, it's a string, but its intention is that it's supposed to be a phone number.
We do this all the time when we write code.
The attacker, on the other hand, they look at the type and they go, wow, this is El Dorado. Because what characters can I fit in a string?
Well, I guess, pretty much any character that is at least a Unicode.
And what's the length of a string?
So, well, pretty big.
Pretty big.
A lot bigger than I would assume a valid phone number is. And as far as I know, they haven't implemented emojis in phone numbers. So, there are things that shouldn't be part of a phone number.
And honestly, when we put it this way, everyone in here goes like, yeah, that's obvious, you should only put in phone numbers. That's our intention. But that's our problem.
So what if we convert the phone number into a domain primitive?
If we have converted it into a domain primitive, we have said that, you know what? I'm going to define something that I call phone number. That's part of our business domain. And it has some exact rules and definitions. Right?
Yeah.
It could be every phone number in the world. That's possible. But then you would have certain restrictions on that, probably. Or it could be phone numbers in the Czech Republic. Or it can be phone numbers inside of your company, right? There could be phone numbers in a different range and all sorts of things.
There's always a strict definition of what that phone number is. It's not just anything.
And the important thing here is that it probably do not accept characters like less than or some like a dash, maybe a dash that could be in there.
It's not going to accept random JavaScript code either.
Yeah. So the phone number domain primitive allows us to have a very exact definition of what we expect. Okay? So domain primitives, they actually enforce our domain rules at creation time. That really means that we cannot now inject something like JavaScript into our method that is supposed to accept phone numbers.
Yeah, so if you want to use a little bit more of security lingo, that would mean we actually reduced the attack vector on this field, right?
Yes.
Because you're no longer accepting the same amount of data, or possible data.
And the neat thing is that by doing it this way, we have suddenly made our code more expressive and clear, right? Everyone who reads it goes like, yeah, that's a real phone number, and these are the rules associated with that phone number.
And another thing that's really interesting, that we haven't been focusing on cross-site scripting when we modeled our domain. We focused on the domain, and we got security benefits as an implicit feature or benefit.
So does that mean now that we can throw out the escaping part?
No. Remember we talked about having security in depth? This doesn't replace anything. You want so many layers of robustness that you can get. So we protected the domain by being very concise, but you also want the other layer. If you're able to input some kind of data into the phone number field that happens to be a valid phone number, but you can also trick the browser, you still want the escaping.
So that's sort of a caked security concept, right? Okay, so when I look at all of this, I go like, yeah, I understand, but come on, Daniel, this creates so many classes. Right?
Yeah, it can, but if you end up having a lot of domain primitives, that's a sign of that you actually have a lot of important concepts in your domain. And if you do have important concepts, you should represent them explicitly in code. If you just ignore them, it's not going to make your life easier in any way.
So you're saying that even though I represent everything as string, objects, or whatever generic types there are, I still need to consider the fact that I have important concepts.
Yeah. And the same goes with, does it get more complex? Well, if you have these important concepts, then you have a lot of invariants and rules about those concepts. And it makes your code and the life of you as a developer a lot easier if you can encapsulate that in this case, in one class, instead of spreading out the validation. If you just have strings or some other generic object flying around, then you're always going to be worried about, do I need to validate this before I act upon it?
So also, I can't really ignore the fact that we have domain rules.
Yeah.
Okay, that sort of makes sense. So I'm sort of stuck. Okay. Oh, wait a minute. Performance.
Okay.
I learned allocating objects is really expensive.
Okay, well, you're kind of giving away your age here, because that used to be a problem, at least in Java world, like, what, Java 1?
Yeah.
1.1? Like,
Right.
seriously, in a modern JVM, this is not you should concern yourself with when you're writing your everyday code. Like, allocating memory and also freeing memory in the JVM is, it's not the main problem you have. You should focus on security and robustness in your code. And of course, some of us are writing systems that have very specific performance requirements, like low latency and so on. And yes, in those cases, maybe this is not a good design pattern. But then you're probably also going to have other problems. But for most of us and for most of the systems that we write, focus on readability, good code that does what it's intended to do.
So most of the cases, this is fine. Well, that's good. That's reassuring. So that means that we have now successfully shown you an example where we can apply a design mindset rather than a security mindset and get security as a benefit.
Yeah.
It's an implicit benefit.
And once you start replacing all your important concepts with domain primitive and that spreads in your code, another benefit that we've seen as a result of this is that you tend to have a lot fewer bugs. Your code becomes so concise and so precise, so it's actually so much more robust in every aspect.
Okay. What about mutability?
Yeah.
I mean, I used to say that mutability is the root of all evil, right? Everyone knows that if you have multiple threads accessing the same mutable state, you need to protect that, right?
At the same time, we all need to handle mutable state. Most applications do. You have state that mutates over time. And we not all want to write single-threaded applications, so we have shared mutable state. That's a problem here. So how can we solve that? Or first, what are the problems with those from a security point of view? So to understand that, let's bring up a term from the information security world, which is called CIA.
You mean like Trump's CIA?
No, not that CIA. This is different CIA. It stands for confidentiality, integrity, and availability. So what's confidentiality all about?
Well, confidentiality is quite obvious, I guess. I mean, we only want authorized users to access data that they're entitled to or allowed to, right? I mean, I'm not supposed to be able to access Daniel's medical records, or he can't access my account and stuff like that.
Makes sense.
Mm-hmm.
All right, so integrity is about, only allowing someone to change the data if he or she is allowed to. And it can also mean that if you're sending data over the wire, make sure it doesn't get corrupted on the way. If you want to alter it, you should be authorized to alter it. That's also pretty obvious from a security point of view. But what about availability? What does that has to do with security?
Availability is a bit trickier, I would say. Availability is really about providing data when it's needed, right? I mean, for instance, let's say my house is on fire, and I call 112, and I say, hey, please come here and put it out. But I can't get through, because someone is, I guess, a lot of prank calls are getting there.
Okay, yeah, that's right. That's a pretty serious security issue. I mean, someone can die in that fire. So
Right.
It has a lot to do with security. And the same goes for, data, even if we think data doesn't have lives and doesn't die, but it's the same thing. The right data needs to be available at the right time in order to be secure.
Right.
So why is handling mutable state a problem when it comes to availability?
So one of the key things here is that since we have a mutable state, we need to protect it from having, parallel mutation, right? Because that can put us in really bad states, I guess. And this becomes a problem also when, you know, we try to scale this application, you know, horizontally, right? I mean, how can we do that?
Okay, so I guess on a code level, you need to start thinking about concurrency, you know, threading. You have locks, and if you lock, you block, and everything.
Yeah.
And also on a bigger perspective, I guess if you have distributed system, you need to think about, okay, how do I handle this? If you start thinking about distributed transactions, well, then you start losing availability and so on.
Absolutely.
But on a code level, you know, is there something we can do in terms of designing code that will allow us to, you know, handle mutable state but still doing it in a safe way?
Definitely. And in order to do that, we actually need to cover two design stereotypes from domain-driven design. The first one we actually talked briefly about previously here, and that's value objects, right? So value objects only care about the actual value of it. I mean, for instance, if I give you a business card, I don't care which business card I gave you, just as long as it is my business card, right? So that makes perfect sense. The other example that you tend to find is, you know, a $100 bill. For us, it doesn't matter, but of course, this is context dependent. And if in a context where you would actually identify this bill, like in the National Treasury, that bill is unique.
Okay, and that makes sense. And we saw earlier that when applying the secure by design concept, we replace the value object with domain primitives to harden your code and make it more precise. Okay, so what an entities is another important concept, which is about handling mutable state. The difference between a value object and entity in domain-driven design is that the entity is defined by its identity rather than its value, right? And it also has a lifespan. So to make it more concrete, let's say you have a customer in a system. You register the customer the first time, it gets a customer ID, that's the identity. As long as the customer is in your system, it may change address, it may change telephone number and so on, but it's still the same customer.
Yeah.
Right? The data changes, but the identity doesn't. That's essentially what an entity is.
So having entities in your software makes perfect sense. And we tend to model these as mutable objects, so to say.
Okay, but since it's mutable, we get all these issues.
Yes. Okay, so let's have an example. Let's go back to our standard one, which we have fixed. You see, we use domain primitives in this one. So therefore, you need to pay $120 now.
No more discount.
Yeah, the discount is off.
So how do we represent the order once you place the order from your shopping cart?
Well,
an order should be, it feels like it should be an entity, right?
Yeah, because an order could actually change state. I mean, it could be, you add stuff to it and remove stuff from it, or you can, get paid, get shipped, and all those kind of things, right? It has some sort of life cycle. Okay.
So it's mutable, but we need to handle shared mutable states. But because once you paid it, you don't want someone to add more items to it and so on.
Right.
So there's a lot of concern there.
And there could be a lot of systems that are going to process this order in parallel. And we want to make sure that nobody, updates this order in a, illegal way or access stuff in there that they shouldn't do and so on. And the data should always be available, right? Because we don't want to wait for something.
So it turns out that there's a design pattern that expands on an entity concept, which is called
Sorry about
two
that.
clickers. That is called entity snapshots. So what if we have an entity that we know that we need to mute its state, but we don't have to represent it in code as a mutable object? We can make it immutable.
So you're saying that even though the concept in our business say it's something that's immutable and has a lifespan and all that, we don't need to represent that as a mutable object.
No, and in order to do that, the first thing we need to do is to separate read from write. Right? Because if you read, the representation of the entity can be immutable. So you can start to behave kind of like a domain primitive. So we get all the benefits from the domain primitive, but it's an entity.
And in the write stuff, we can actually make sure that we are fully optimized in doing only mutation. We don't need to care about read. That makes sense. Yeah. Especially when you think about, there's a concept on the internet where you actually type in a URL, you get some data from a server, and it gets rendered in your browser. that's actually a snapshot of that data that's on that server.
Yeah, because on the server side, the data may change over time, but your snapshot is being immutable. It's not going to change until you reload the page or if you get a push notification or something like that.
Right.
So it's the same concept. We're used to this.
Okay. So that's pretty interesting. Let's see how this affects our order now.
Okay, so conceptually, we would have something like maybe an order read service that we go to read the order, and the object that we get back is an entity snapshot. It's, it's immutable, it upholds its invariance on the construction time, so it's always valid. It behaves like a domain primitive, but it's not, an entity. And when you want to write, you go off to another service called the order update service, and you say, please update this value to something else.
Okay, so that makes sense, but once again, isn't this, performance-wise quite expensive to do this?
Not really. I guess it depends on what you think about performance, but you could say that you can actually get better performance. Since you're separating it, you can focus on one thing. Let's say you have an override on either the read or write side, right?
Okay.
So the read side never has to worry about contention because it's immutable. The write side needs to worry about contention, but depending on how the data flows in your system, you can actually get better performance when you separate things.
Okay, but still, isn't this really complex to maintain, I guess, consistency between the various snapshots that exist?
Yeah, well, since the snapshot is essentially behaving like a domain primitive, it's immutable, means that the snapshot will always be valid. Because it's a picture of a point in time, and at that point in time, the data that the snapshot represents is valid, and it was valid, and will always be valid.
Wow, that's actually interesting now when I think about it. So every snapshot that's taken is validated. That means in that point of time, the order looks this particular way, and you can act upon it. And since we are enforcing eventual consistency, every consumer of this will eventually have consumed the last version of that entity, right?
Yeah, and on a code level, it tends to be less complex. If you're writing, you can just focus on that logic, that type of infrastructure, and so on. And you can also start, experimenting with, you can pushing down the logic of keeping consistent state to infrastructure level, for example, so you don't have to worry about it in your own domain logic.
Right. Okay, interesting. So now we can say that the entity snapshot actually solves the availability problem by simulating the properties of a domain primitive, right? Because a domain primitive is immutable, the same goes with the snapshot, and it allows that to scale as many copies as you want, right? So data always becomes available, right? And the consistency part is that, eventually everyone will have the same one. Okay, interesting. So this design pattern can help us address mutable state in a distributed system. Okay, so now we've learned a design pattern that, first of all, we fixed certain injection flaws, right? Like, cross-site scripting with domain primitives. We also learned how we can handle mutability in a pretty nice way without thinking about the various security problems, rather than we're thinking about, scalability and sort of things. Okay, but what about this, accidental leakage?
Yeah, what do we mean by that? It's very common. It's a very common problem. It essentially means, typical cases is that you unknowingly write some data into a log file, for example, and the data happens to be sensitive, so you have to protect it, but you don't know it, you don't think about it. Another example can be, if you have sensitive data in a section in, let's say, a web application, that can sometimes accidentally get serialized or persisted somewhere. I know, like, for example, Tomcat, which is a popular application, has by default, if you shut it down, it's going to try to serialize all the session data down to disk and then read it back when you restart it. So what if you have sensitive data in your session is going to end up on disk, possibly unprotected? Another issue that is very common is that you're evolving your business domain. So an object or an entity or something can be totally innocent and doesn't contain any sensitive data, but as you evolve your domain, you add new features, suddenly it starts to contain sensitive data. And that becomes a problem.
And that is something that I find very interesting because, usually when you design things, of course you're going to think about sensitivity in that time, but over time you don't understand how things evolve, right? So if you look at this particular model here, we have a user, right? And when we modeled it, we said, this user should have a name, a nickname, and an age. Well, let's say there's nothing sensitive about that. And what could happen then?
Well, then let's say, a year later or something, you add more features and you realize, user should really contain a social security number also. And that happens to be sensitive in our context. And suddenly, the object that we used to have that wasn't sensitive, we could use it anywhere, we can put it in logs and anything. But once you add this, in practicality or in real life, there's no chance we can go back and review every single code that we wrote a year back. So you're not knowing that the sensitive data is suddenly going to turn up in logs and things like that. And this is a very important subject, especially in Europe, where you have things like the GDPR, that some of you probably have heard of, where you really need to know where sensitive data is. So, slipping this out in logs and everything, that's a real problem.
Right. And especially now if you put this inside of the session, right? Which is the normal place to have it, I guess. And if you had to use Tomcat and you haven't disabled this session persistence thing, well, then suddenly that data gets on disk and it gets externalized, right? Which means that somebody can access it.
Or maybe you're sending it over the network, and instead of explicitly picking out some fields, you're just running some library that will extract, use reflection or whatever, just take all the data, and suddenly you're exposing sensitive data that you didn't think you did.
So protecting against this is really hard, but we can help detecting it. And for that, we actually have a design pattern, right?
Yeah. We call it the read once object. So this is an example of how you can apply the design pattern. In this case, we decided that in our domain, in our applications, this particular value can only be read once. Okay, and typically you will do this on a domain primitive also, so it has a meaning. So in this case, we're going to allow the extraction of the value once, and if you try to read it again, we're just going to throw an exception.
So you're saying that we have analyzed our domain, and we have decided that, this piece of data that we have decided that is sensitive, it should only be consumed as at these various places. And that could be 1, or it could be 3 or 5 or whatever it is. But after that, that data is supposed to get destroyed.
Yeah. So what if I, somewhere in my code, accidentally or indirectly put it in a log file? That's very typical case. Then let's say I do that before I actually use the value. So the sensitive data ends up in the log, but then when I actually try to use it by the domain rules, it's going to blow up. So
exactly.
Hopefully I'll notice that in my test suite, otherwise I'll notice in production. But your program is going to start working. So we haven't prevented the leakage, but we're going to detect it pretty fast.
And I guess some of you, anyway, are working in legacy code. At least I am, yeah. And one thing that we did there was that we started to analyze our domain objects and went like, yeah, this data here is sensitive. And we guessed that, yeah, it's only supposed to be consumed here and there, right? And when we added that, we realized that, wait a minute, this other module over here is actually logging this. They're logging everything. And things started blowing up. And then we can address it. We can say, oh, is that fine or is it bad? And that's a great tool to have in your toolbox in order to find these things.
Yeah, you can evolve and expand on this pattern. So for example, you can say that, well, I'm not going to allow serialization, so I might throw an exception if someone tries to serialize it. I'll think about not including the actual value if someone is calling toString and so on. And you can tweak it, but the point is you'll detect if you're doing a mistake in using it, because that's probably more common that you accidentally is leaking data rather than someone going in and stealing it from your code base.
Right. Okay, so now we've actually seen 3 patterns, right? And these patterns can be summarized this way. The first one, domain primitives, that allows us to create very precise and exact definitions of important concepts in our business domain. And these ones help us to avoid malicious injections.
Yeah, and it does so by us being very specific on what it is, and also very important what it is not.
Yeah.
Right.
And of course, the read once object, that pattern is sort of a mechanism for us to detect where we would accidentally leak things. It's like unintended leakage, right?
And then we've looked at how do we handle mutable state? How do we do that? And we can apply the entity snapshot design pattern to get the same benefits that we did from domain primitives, but we can apply them on mutable state.
Right. The only problem in this entire talk has been one thing. And that's the 3 words that says secure by design. Isn't that a book?
And here's our shameless self-plug. We're currently writing a book, me, Daniel, and a guy called Dan.
Yes.
On this topic, we're trying to, with so many ideas that we're trying to put down. It's not finished yet, but it's available in the early access program. And if you're at GeeCON, you can use this promo code and get, 48% off the ebook?
Yeah, don't put in -1 there. No. Don't try that.
Don't try that.
No. But this access code gives you a opportunity to join the early access program that you can use to give us feedback in our process. I think we have published 4 or 5 chapters there, but we've written a lot more, and it gets published, monthly.
Yeah.
And you can give us feedback, say, hey, I don't understand this, or this doesn't make sense, or this is brilliant. Hopefully you say a lot of stuff like that.
We don't agree or anything. So it's always good with feedback.
Yeah. So please join. Now we actually have some time for some Q&A, I think. There's a question over there.
How do you maintain the version of the snapshot?
So,
Because I think about, for example, if a customer wants to pay for the order, he has to pay for last snapshot.
so the question was that how do we maintain the version of the snapshot, because a consumer only wants to pay for the last version of that order, right?
Yeah. So I guess if I understand it correctly, it's kind of like if you have this distributed or eventual consistency, how do you manage an invariant that spans over like time or states? And that's a very interesting subject. Now I was at Java 1 last week or so, where I saw Chris Richardson talk about a pattern he calls sagas, which is kind of in the line of these things, where you extract upholding the invariance that spans over various states. You can extract that from the actual state objects. You put it somewhere else, and then you can either put it, how you technically do it. There are different options, but that's a very interesting approach in how to handle, invariants that are eventually true, so to speak.
And also it would be that, I guess your domain logic would be like, let's say you have pushed some sort of checkout button or submit button or whatever it would be. And that order now, and you write the operation of saying, this is now moving over to this particular state. And all the consumers of that will, of course, react on it. And especially if there would be a consumer that would say, I'm going to initiate the pay flow based on that. And it wouldn't do that before it actually has that set in there.
And of course, depending on your use case, maybe you can get away with using some kind of optimistic locking approach, where you say that, okay, I'm trying to act on this, but then whoever is receiving that command is just going to say, well, you're trying to act on something that is stale.
Yeah.
Please try again. So you have to. It kind of depends on your context.
Next question. Amazing. This was crystal clear.
Yeah.
Yeah. Another question.
Yes.
How can I use these patterns on the persistence database? Could I do some domain primitives on the database level?
So the question is that how can I use these patterns on a persistence level? Can I use domain primitives in the database? That's a tricky one.
Well, I guess then let's say if you're in the database domain, then you're worried about things that is about the database. And I guess I'm not a database domain expert, but I guess you will always have constraint. Like if you have a field of a certain type, then it can, let's say it's a string, then it can't be a gazillion signs, or is it just 255, or So then those would be your invariants in your current context, and that's really the essence I hear. I think in the term current context. So if you're up in the business logic, then that's the context where you want to apply the invariance. And if you move down to persistence, then that's a new context. You have to think about what rules do I have in this particular context, in terms of persistence. What is okay and what is not okay in persistence. Does that answer your question? Great,
Okay,
thanks.
All right, I think we're out of time. So
Yeah, I think it's about time for lunch too.
yes. All right, thank you so much.
Thank you.